Hello, and welcome back to our series exploring the Automated Drone Image Analysis Tool, or ADIAT. My name is Charlie Grove. I'm the Director of Technology for Texas Search and Rescue, and I'm the creator of ADIAT. In this video, we're going to do a deep dive into the three RGB-based algorithms that we have in place in ADIAT today. And these are the algorithms that would be used for color images that come back from a drone or whatever other source. Let's go ahead and get started with the first one, which is our color range algorithm.
So the color range algorithm is one of our two color detector algorithms that we have in place. In fact, it was the first algorithm implemented in ADIAT. And the way it works is it looks at each pixel in an image to determine if it's within a user specified color range. And we'll talk a little bit more about what that means here in a second. Once it goes through that process, any sufficiently sized areas as defined by the user, as we saw in the general interface walkthrough, will be identified as areas of interest and flagged in the output image. Looking at the input variables or parameters for the color range algorithm, we have our base target color, which is the, hey, this is the perfect match color. And then we have the RGB, which are the red, green, and blue plus or minus values for the channels. And that's what defines that color range for us. So it gets a little conceptually hard to wrap your head around sometimes because we have three variables, R, G, and B. So we're talking about a cube of color like this, where we have the red axis, the green axis, and the blue axis. So three-dimensional thinking here. What we're trying to do is carve out a section of this giant cube and say, hey, these are the colors that meet my criteria. These are the ones I want to look for and consider to be a match for my target color. We see the RGB space here. It goes from 0 to 255 for each channel. And if we go ahead and pull up some sample input, we'll say, okay, for this one, our target color had a red value of 75, a green value of 0, and a blue value of 255. For the red channel, we gave it a 25 plus or minus range, green 50, and blue 50. For red, we go from 50 to 125. In green, we can't go any lower than 0, so we can only go in the positive direction. So we go from 0 to 50, excuse me. For blue, we can't go any higher than 255, so we go from 205 to 255. So just something to consider when you're picking colors. If you pick something that is near the extreme for any of the color channels, you are going to have a smaller range than you might anticipate because we can't give it that full plus or minus 50 in this case because there's just no more room to go. We hit the lower limit or we hit the upper limit. What this looks like when we carve it out from our cube is basically this. We take that chunk out and say, okay, this box that we've defined with these ranges is now our color range. Here's what that looks like. Again, anything that meets these criteria, anything that would be a color that is somewhere inside this three-dimensional cube is a match for our algorithm. With that, let's go ahead and take a look at it in action in ADIAT. All right, we're back over in ADIAT now. I went ahead and set up my input and output folders as we discussed in the previous video demo walking through the general interface. I have my min object area set. I have my max processes set because I've run this algorithm before on the setup, and I know that's kind of the sweet spot for my setup where we get the most efficient utilization of the computer resources. And we have our algorithm set to color range. If I go to the color picker, I can go ahead and select a color. So we can do blue, we can do some shade of red, we do whatever you think you want to be looking for. As I mentioned, be careful when you get into these maximum values because that's going to severely limit your availability of the color range because you can only go one direction or the other. But for our purposes, since this is, well, this one actually should work out for us. So I'm going to select our light blue here, which is what we used in the general walkthrough demo. And then I'm going to set those ranges. I'm going to set them a little higher this time. I'm going to say 100, 100, 100 so that we can see what this does. So we have a viewer here to help kind of show you the min, middle, and max. So this is your target color. This is the darkest version. This is the lightest version. Again, we're trying to show kind of a visualization of a three-dimensional space. Kind of hard to do. The other way we show that range is in our view range pop-up here. And you'll see, again, it's not fully three-dimensional, but it gives you a pretty good sense looking at this of, okay, these are the colors that it's going to match and say, hey, that matches our shade of blue. We should go ahead and consider that a match. So you can utilize those two tools to give you a sense of what you're going to be selecting here. Once we have that set, just like before, we can hit start. We're analyzing our same image set. I did change the ranges a little bit, so we'll see what our results are. If we see more areas of interest, I would expect to see maybe a couple more since we widened our net a little bit. And in fact, now we have 59 images with areas of interest instead of, I believe it was 26 before. If we go to see the results, we see since we widened that range, we're getting a couple more false positives. So it hit on some discoloration on, I think, a doormat there. Like the doormat, and now it's finding that dark blue shirt. It's dark blue and light blue, dark blue and light blue, dark blue and light blue. Those were the two things I was hoping to find. So yep, we see we're consistently hitting on those objects that were placed in the field. If we go back to this, let's choose something extreme like this pure red. So this red is 255.00. If I'm going in to use this tool now, I kind of have that decision point of, hey, I know I'm looking for something, a red shirt. Am I sure it is that red? Do I want to fudge it a little and go more towards purple or more towards orange or something? Or do we want to stay at pure red? If we look at the range as is, we see it is a smaller segment than we saw with the blue, simply because that just doesn't have the variability in the range. Let's go ahead and run this, simply because red is a color that stands out pretty well in nature, so we should still have some good results with it. And we found 71 areas of interest. Let's see what we found this time. We got our red shirt that it found. Yep, red shirt, red shirt, red shirt, red shirt, red shirt. And again, I'm using the keyboard shortcuts of the left and right arrows. That's why you're not seeing anything happening on the screen. We can also go previous and next. Now it's actually hitting on an orange shirt, but again, it was in that color range since we cast a fairly wide net for the color this time. And it continues to hit on that and back to our red shirt, and it should be sufficient to show, hey, yep, it's hitting on what we expected to hit on. Awesome, it's working as intended. I'll save a little bit of time at the end of this video to talk about how you pick the color. It's probably one of the harder things to get used to with using a tool like ADIAT, is deciding what is the right shade of red or blue or green or whatever color it is to use as my target color, and then set that range from there. One note though, as we before we leave color range, again, don't be afraid to set these ranges pretty wide. If I put this way down at like 25, 25, 25, you see the high, medium, low are really similar there. And if we go to the range viewer, that is a tiny sliver of the color space that we're actually looking for. It may seem like I know exactly what shade I want and I'm looking for red, but widen that net a little bit. You'll get much better results in the long run if you do that. All right, the next algorithm we're going to look at is our matched filter algorithm, which was added with version 1.2 of ADIAT. So the matched filter algorithm is our second color detector algorithm. And the way this one works is individual pixels are scored based on how close they are to a reference color or a target color that is selected by the user. Then, like with our other algorithms, once the scores are calculated, we identify areas of interest, much like we did with color range, and anything that is a sufficiently sized area of interest is flagged in an output image. As far as how those scores are calculated, we have the mathematical equation down here at the bottom. There's also a lot more reading you can do if you're interested in that side of things. The links are on that texar.org ADIAT page. You are more than welcome to do that research. Good information to know, but by no means necessary for just using the algorithm in ADIAT. Just know that the way it works is it's going to score each pixel based on how close it is to the original target color. and then select areas of interest from that. Inputs you provide this time are the target color or reference color, and again, that threshold for how close to the original color must something be for it to be considered a match. Don't get bogged down in the math on this one, at least for now. Just know that higher threshold values mean that it must be closer to the original color. Lower threshold values mean it will not be as selective with matching. So how does this work? If we have our input image, our RGB image here, we convert that to our RGB values with our sets of 3, like we've seen in some of the earlier videos. We have our red, green, and blue channels. What happens is those values are then scored through this equation, and values are generated saying, okay, this one, was a value of 0.77 versus 0.67 for the one next to it, etc., and so forth. Each individual pixel is assigned a score based on how close it is to that target color. We then essentially do a true-false comparison and say, hey, is that score greater than whatever the threshold is? If the threshold was 0.7, then yes, yes, no, 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 no. All the zeros are no's, all the ones are yeses. So long way to get to it, but all we're doing in the end is saying, okay, is this pixel close to this original color that we selected? And we can go ahead and look at that in the tool as well. All right, we're back in ADIAT now, so I'm going to switch from our color range algorithm to our matched filter algorithm. We have our 2 parameters we need to set, the color and the threshold. Let's start by picking a color. Let's go back to our favorite blue. And now the question is, how the heck do I know what threshold to use? Well, we do provide that view range capability like we had for the color range algorithm. And if we click on that, you can see at 0.3, it's a pretty broad range of colors that would be considered a match. So we usually try to bring that up a little bit and be more in the 0.7, 0.8 range, depending on how confident you are in the color that you are looking for. So if we bring that up to 0.7, we have a much smaller color range that we're looking for, much less likely to end up with tons of false positives, finding things that aren't actually all that close to the color that we were originally looking for. So having those 2 parameters set, we can go ahead and hit start, and it will start running. Now, you'll note pretty quickly here that the match filter algorithm is slower than the color range algorithm. In fact, the color range algorithm is by far the fastest of the ones that have been implemented for RGB, just because technically speaking, it is the most simplistic and requires the least computational power. So whereas the RGB or the color range algorithm was finishing the same set of images in somewhere between 11 and 12 seconds, the match filter algorithm will probably take somewhere around a minute to get through the same set. Slower, certainly, if you have the criteria and the information you need to use color range, it's probably a good place to start. If you're more comfortable just selecting a single color and saying, hey, somewhere close to this with a threshold, still not bad for match filter. You're still right around a minute and maybe a little slower. 61 seconds this time. Again, not too bad considering our screen recording and doing all sorts of other things in the background. But now that I've managed to talk over the 61 seconds of that running, we can go ahead and look at the results for it. And much as we saw with our color range algorithm, we are finding that light blue shirt. Let's see if any of these picked up the dark blue shirt. I mean, we can see the dark blue shirt in these images, and it is not picking it up, so that might be a sign that the way we set that parameter was so finely tuned that I was only looking for light blue and not dark blue. Maybe you want to be that prescriptive with your analysis, maybe not. Maybe you want to cast a little wider net. Again, all dependent on your scenario, on your backgrounds, all those sorts of things. So as you see, works much the same way as the color range algorithm in the end. It's just instead of manually setting that range yourself, you just set the target color and a threshold, and it does the rest of the work for you. All right, having looked at both of our color detection algorithms, we will now move on to the RX Anomaly Detector. So the RX Anomaly Detector is unique from the previous two algorithms in that it is not color specific. You are not going to provide an input color and say, I am looking for something blue or orange or red or what have you. All you're going to do is set a threshold, and it is going to go through a scoring algorithm somewhat similar to match filter, but just saying, hey, does this color pixel make sense in the context of this image? And that's what we're describing here. The RX Anomaly Detector extracts targets that are spectrally distinct from the image background. Once the arc score is calculated, each pixel is scored, and if anything is sufficiently sized from an area of interest standpoint, it is flagged just like all of our other algorithms. The math for this particular algorithm can be seen here. Again, if that's something you're interested in, a lot more of the theory behind this, by all means, check out the Texar website, the ADIAT page. We've called out a couple of resources with a lot more information about how the RX anomaly detector works from a theoretical standpoint. The input parameters for this one are the threshold and the image segments. So image segments is a new concept here, and I'm actually going to talk a little bit more about that rather than go through a slideware demo of how the image analysis process works on this one, because frankly it would look pretty much the exact same as matched filter. You go from an RGB image, the RGB values to scores, etc., and so forth. Same thing, areas of interest are identified the same way. Image segmentation, in this case, is basically us taking this image and breaking it up into smaller images. So since this detector works by comparing a pixel to the rest of the pixels in its picture, if we have a busy image like this one, and I'm going to pull that grid back off for now, a busy image like this one, we don't really want to be comparing the pixels in this field over here to the pixels of these cars or the building or whatnot and trying to say, is this anomalous given everything else going on in the image? We're better off saying, okay, I just want a small chunk of this image and compare that pixel to the rest of the pixels in that chunk of this image. So we introduce this concept of image segmentation where you can break down the image into 2, 4, 8, 16, 25, 36 individual images and do the analysis in those blocks rather than the overall image. Once that analysis is done, the grid is all stitched back together as if it were a single image. And we can take a look at that in the tool as well as the RX anomaly detector now. All right, we are back over in ADIAT now. I've switched over to the RX anomaly detector and we see our two input parameters here. As noted, there is no color selector for this one. We are just flagging anything that is deemed to be anomalous based on the RX anomaly scores. So we can set our image segments. I'm actually going to leave it as 1 for now, just for our base use case. And then we can go ahead and set our sensitivity. Higher sensitivity means something must be more anomalous before it is considered interesting. Lower sensitivity means that we will catch more stuff. Now, it should be noted, because we are not selecting a specific color here, anything is fair game. It doesn't matter what color it is. So you are going to get a lot more false positives with the RX anomaly detector. There are some specific use cases for which it makes a lot of sense, and it's also useful in scenarios where you have no information about what the subject was wearing. So for our purposes, let's drag this up to 8 for now and go ahead and get start. So we saw the color range detector algorithm was somewhere in the 10 to 12 second range for 158 images. When we ran the match filter algorithm, we were at 61 seconds. RX anomaly is going to take a little longer than that just based on the scoring mechanism and the computational requirements of that. So I will actually speed this up and we can see the results once it completes. All right, we completed our run there, 82.5 seconds roughly for the RX anomaly detector. We see it found a lot more images with areas of interest because again, it's not limited to a specific color. So anything with Whatever it decided was interesting goes ahead and gets flagged. Let's see what it decided was interesting on this run. So as promised, we are going to get a lot more false positives using it in a scenario like this. In this case, this particularly bright patch of this branch was interesting to it. And more branches, but hey, this time we found the red shirt, so that is something we were looking for. Red shirt, red shirt, red shirt. Red shirt and our landing spot, so it found that guy over there in the corner. Blue shirt, blue shirts. Our orange shirt, so it is finding the areas that we would want it to find. But this is a great example of it's finding what we want it to find. It's also finding particularly interesting looking bushes in its assessment. So just something to be aware of. It's a great tool if you're not sure what color you're looking for, but you will have to go through a lot more images. It does take a little longer to run than the match filter algorithm, considerably longer to run than the color range algorithm, but it is still very beneficial. There are definitely use cases where it is the right choice. So one example of where the RX anomaly detector makes a lot of sense is a scenario we had not too long ago where we had the opportunity to go down to the Texas coast and work with the US Coast Guard on an exercise. So that's a great opportunity for the RX anomaly detector. If you're looking for stuff in the water, the background is going to be fairly uniform. So anything that isn't water, isn't flat green, is going to really stand out and be of importance to us. So if we run the RX anomaly detector over this small set of images from this exercise we had, in this case, I think I only put 6 images in there. Go ahead and let that run and view the results. We can see, yes, it identified, the white caps in the water, but it also identified individual birds. So if you can imagine the size of a bird compared to the Gulf of Mexico or this area of the Gulf of Mexico we were looking for, the RX anomaly detector is a great option if you're looking for a lost swimmer or somebody in the water or anything like that. We're going to have a fairly uniform background. And we can see that on a few of these images where it finds the bird, finds, I guess, a diving bird in that instance, and then just another anomaly in the water there. So something to consider. Definitely a time and a place to use the RX anomaly detector. Don't discount it just because you're going to get a lot of false positives in some scenarios. Absolutely keep it in your back pocket. It's a tool in the toolbox for when the time calls for it. So a couple of tips, tricks, suggestions before we close out this video. As I mentioned, when you're using the color detector algorithms, the first question is, well, what base color, what target color do I select to start with? And a few ways you can go about that. One, if you're just going completely off of, hey, they were wearing a red shirt or a blue shirt or a purple shirt or what have you, awesome. Go ahead and select some hue version of that. If you can get away from the extremes, as we mentioned, keeping these away from 255 or 0, that'll give you a broader range of possible colors because it will be able to go above and below when it's trying to match. If you happen to have similarly colored articles of clothing available in the field, there's nothing wrong with throwing a t-shirt or something out there, sending the drone up, have it take a picture of that, and then going into Photoshop or whatever you want to use and just use the eyedropper and pick a color from that and say, okay, well, I know what this color shirt looks like in this lighting from this altitude, so let's assume that the subject wearing a similar color shirt will end up looking similar. So you can do that to get your base color. The other option we have, if neither of those is available, is there's a couple of websites I like to use, and I will put the links to these in the description below. First one is Pantone Colors. So this is a great site that gives you all the different Pantone colors. We can see more of the earth tones here, more of the reds, pinks, fuchsias, those sorts of colors, into the purples, into the blues, etc. and so forth. So lots of good colors to choose from here. If there's something here, if you're sitting with the family or friend or whoever who happens to know what they're wearing, you can go through the site with them and tell them, okay, pick the right color for me. Tell me which of these colors best matches what they were wearing, and we can go from that. The other site we like to use is this one, and I will say up front, I am not affiliated with either of these sites. Texas Search and Rescue is not affiliated with either of these sites, but they are useful resources to us. This one specifically talks about types of denim and colors of denim. So, at least in the US, a lot of people tend to wear denim jeans when they go outside. So, this is a cool resource that gives you a bunch of different colors of denim that you might be able to select from to say, hey, this is the sort of wash or the sort of coloring that they had in their on their jeans. Let's start with that as our base color and go from there. One call out and just something to keep in mind, especially when you're doing color detection, the further you can get from earth tones, the better off you're going to be. The further you can get away from black and white, the better you're going to be. Anything that is going to stand out against the background is going to be really where these tools shine or where these color detection algorithms shine. If you're wearing something that's going to blend in, if you're wearing camo, if you're wearing browns, anything like that, it might not be the right tool for at that time because the reality is it's just not going to stand out against the background. They're designed to not stand out against the background. So just something to be aware of. Use the right tools in the right time. If the subject happens to be wearing a color that is not going to be visually distinct from their background, maybe they're looking at the RX anomaly detector, or it might be time to start looking at thermal image detection, which is where we will go next in our next video. Until then, thank you very much for your time.